Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. In this video, we are going to learn about defining a variable. This is going to be a very basic understanding for your programming, and of course we are going to learn and develop this basic understanding in the environment of Python. And there are going to be a few other things around this basic understanding, defining a variable, that we're going to see in this video, such as how to cast a variable, such as how to check what is the type of a variable, and things like that. All right, let's look at what we have for this video. All right, so when we talk about defining a variable, basically variables are containers of information, right? They're containers of value, and we create a container to retain and hold some value for some use. And we have types of different values, and the four basic ones that we can use in Python are integers, 1, 2, 3, 4, 5, so on and so forth. Floating points number, 1.2, 500.1. Anything that has a decimal point, that's a floating point number. And then we've got strings and booleans. So these are the four basic types of data values. These are the four types of values that we can create variables for. And one thing that is very different in Python and perhaps a little bit older programming environment is the fact that in the older programming environments, you had to declare a variable. Let's say you would say, I want to create int, the name of the variable, my number. I want to create an integer, a variable called my number as an integer. And then you would assign the value to the integer. The good things about Python is the fact that you don't need to do that declaration. By assigning something to a name, the variable is going to be created, initialized, declared, and at the same time the assignment is going to happen at the same time. So that makes things easier. So let's go ahead and start some variables together, right? So for instance, let's say a is equal 200, right? So once I run this, a is created, and if I say a here, then a is 200. I could have said something like a is equal to true, right? And then it would give me true. I could have said a is equal true as in a string, and then it would give me true as in a string. I could have said something like a is equal 2.15, and then it would give me 2.15. So let me go ahead and create a few ones here that we are using different types of variables. So for instance, I am going to say b is equal to 200, c is equal to hello world, d is equal to false with capital F, and e is equal to 1.768, right? So I create all of these variables, and now once I call them, I can sort of like use or see those values created for me, right? So you can see defining a variable and assigning it is very simple. It's very intuitive. I want in the future to work with something like b. I want to use this variable in the future. So I say, okay, here you go, 200 is equal to b, right? For instance, I could do some calculation as well. For instance, I want to calculate a formula that it's going to be, I don't know, a multiplied by b divided by 2, right? So I say my a is 10, my b is 5, and I want to calculate a multiplied by b divided by 2, right? So once I run this, now the calculation is done for me. Now I can change this into 200, for instance, and the calculation is also done. So I just need to change the assignment part, and the formula is going to work for me. So that's defining a variable. So as you can see, it's very simple in Python. Another thing we can do using Python is to check the type of variable, right? So we created these A, B, C, D, E variables, but let's go ahead and use this function type, which is a Python function. When you say type, it changes color. You see, the color changes to green, and we can just say what is the type of, for instance, A. And once you run it, it tells you the type of A is integer, right? So let me create some boxes here, and then, for instance, what is the type of B, right? So A was an integer, B is also an integer, right? How about what is the type of this calculation, right? What is the type of this calculation? It's a floating point, right? So you can see it's float, means floating point. And we had other variables here. We had C, D, and E. Let's check out those as well. So we've got type C. Let's see what it is. This is str, or string, right? Do you remember? This is in a string. Let's check type D, right? So D is a Boolean, right? So it's one of those 4 types, Boolean. And finally, if we check type E, it's going to be also a floating point, right? All right, the floating point. So another thing we can do in Python very simply is casting. Casting is the idea of changing the type of a variable, right? For instance, right, we have A equal to 200, right? And we want A to be recognized as a floating point. I could say something like float A, and then it will change that into a floating point. The number doesn't change, but since it's a floating point, the dot, which shows a decimal, indicates decimal, is shown here, right? You could have done something in reverse as well. For instance, you could say B is equal to 1.54, and you say I want to cast this as an integer. Once you do this, once it casts as an integer, does not have the capability to have the decimal points, so it just gets rid of all of the decimal points, right, from A to B. For instance, you can say, let me see if I can cast 1.54 into a string, right? So you could say str, and you could say B. It will create this as a string, right? Let me see if I can cast a string into an integer. For instance, let's call this, my string, because this isn't a string. And now let's cast this as an integer. Once we do this, this is going to give us an error, right? Because those values cannot be cast as numbers. I mean, there is nothing that is number-like. The string cannot be cast as an integer. And that's not going to work. But I believe if we say float, this might work. Do you see? And another thing we can check here, for instance, let me change my string into hello, right? So my string is hello now. Even if you wanted to change it to float, this is going to give you an error, right? Or an integer. So when you're using this cast, you have to have some reasonable understanding and conviction that the cast is going to be possible. And if it's not possible, you are running the risk of receiving an error, right? So you want to pay attention to that. But during the programming, you might need this casting, and that's going to be a useful function to know. Another thing we are going to learn in this video is we're going to learn about naming variables. I mean, the naming variables, what we mean is just these A, B, C that we've been using, right? For instance, if we created A, B, C, D, E. So how did we come up with these? There are a few rules to follow here. We cannot name a variable would start with anything but a letter. So for instance, we cannot say for BS as a variable, right? If we do this, it's going to give us an error. It's a syntax error. Or you cannot have numbers in between the name of the variables, right? This is going to work no problem. But you can only have letter or numbers. You cannot have something like, for example, this $sign or pound sign. If you run this, it's going to give you an error, right? The only thing that you can have is letters and numbers and underscore. These are the only thing you can use when you are creating a variable. And one thing you want to pay attention is the fact that the naming is case sensitive, right? So when you have age, for instance, right? This is different than age, right? Because it's case sensitive. It's matter that this is lowercase but these are uppercase. If you run this, it says age has not been defined just because the variables are case sensitive. This is different than this. And another thing you want to pay attention is we don't want to use the reserved words. For instance, we saw that str is reserved for a string. This is reserved for integer. This is reserved for boolean, right? And what's going to happen if you were to inadvertently use them, or just make a mistake and use them, your code is going to just work fine, right? So for instance, I'm going to say integer is equal to 100, right? So this is going to work, and once you say integer, this is gonna work for you. But what's gonna happen is that when you need this, this as a casting function, that's not going to work for you anymore. It's going to give you an error. So let's, for instance, look at here. Integer, I want to cast a floating point into this function, and now gives me an error. It says integer is a variable, it's not a callable object, right? The reason is we just changed that reserved word, and we shouldn't have. And once we do this, now this has a new identity that you have given to it. When you make such mistakes, the only thing you can do is to reset the kernel. So once I reset the kernel, right, pay attention, we had 30, 40, 41, runs on these chunks. This is going to start from the beginning. And if I do this now, this is going to work because, when you reset the kernel, none of the variables that you've already defined is going to be remembered. You wipe the slate clean when you reset the kernel. Once you do that, the only way to make sure that this mistake is not happening, it's not like in the kernel anymore, is to reset it. So let me go ahead and remove them. Maybe just keep them here as a reminder. One of the other things I want to talk about here is how do we go about multi-words variables naming, right? You could name your variable anything you want. Like, you could, do something as crazy as this, right? And this is just going to work for you, right? You can, still call this, and there is not going to be any problem as far as using this. But you have to agree, using such a variable is not going to help your code to be readable. So for us to make our codes readable, when we have to use more than one word as our variable, there are three ways we could go about this, and all of them are great. You could use a camel case. For instance, we could say my variable, right, is 100, right? So now it's it's standalone as one variable as a name, but at the same time you can read it, right? So my variable is 100, and now we can run this and you've got it as 100. Or you could use a Pascal case. It's very similar to camel case. It's going to be my capital M variable. Again, let's say call 200. And once you call this, it will be 200. And the snake case is going to be my underscore variable. This is also going to work just fine. So these are the three best way to go about naming your variables when they have more than one word in them. And you can see this is camel case. Why it's camel case? It looks like a camel that has a hunchback, like because of the leather here. And then this is Pascal case, and this is snake case because they're just like one following the other, so it looks like a snake. And the last thing we want to talk about here before we look at an example is to how we can assign more than one variable, the value to more than one variable in just one line. For instance, I have my variable. Of course, these are all going to be different, right? And my variable, right? I have three variables. I mean, they all have the same name, but they are camel case, Pascal case, and also snake case. Now I can assign 100, 200, and 300. Instead of what I had to do on each line, I can just do this in one line of code. This is a very good space saver, basically, right? Let me copy these. So instead of having to do each of these assignments in one line, we can just go ahead and do this in one line, all of them, and that's just going to be a great space saver. And this is something that Python accommodate with it, right? So that's good. So let's end this video with an example. So I'm not sure if you are familiar with the concept of economic order quantity, EOQ, which is basically what is the best optimum number I can order to minimize my cost as far as cost of the order and cost of the inventory, cost of holding materials in my warehouse. And there is a famous formula for this solution for this economic order quantity is the square root of this division whose numerator is this calculation. So we've got in this formula we've got three parameters. We've got S is the setup cost of ordering, we've got D is our demand, and we've got H, which is our holding cost, right? And we have been given these values. Now we want to, in just two lines of code, to come up to the answer using Python, right? So, the way we go about this is very simple. So we say, okay, let me just use one line of code to get all of my, parameters. So I've got S, D, and H, right? So my S, which is the setup cost, is being given as 4,000, right? So this is 4,000. And my demand is given as 500, so I put 500, and my holding cost is 20% of each item, right? So it's going to be the value of each item is 500 multiplied by 0.20, right? So I can actually do some calculations in there too, right? And then all I need to do is to do the calculation, right? So this is going to be that calculation. And we can check if MATLAB has the SQRT, but it doesn't. You can see, right? It doesn't. So we have to, use our mathematical skill to say, okay, if Python doesn't have, square root, we can, use our mathematical skills, which is the square root is going to be equal to power to half. If you power a number to 0.5, it's basically a square root. So the operation for powering is 2 star on Python, and power to 0.5 or half is just going to be a square root. So once we run this, we get the economic order quantity as 200, right? So you can see you can use these parameters, these variables, we sort of use these parameters as variables and do this calculation very simply. The good things about creating variables, defining variables, is that you can, do the same calculation very easily. All you need to do is change values. So I'm just going to copy this. What if the demand is, raised to 700 monthly? You can just change this to 700, and there you go. There you have your new value. All right, until the next video.